What's up, everybody? Mr. Rosen here. Today we're going to observe two reactions involving balloons. The first reaction is going to involve a balloon which I have filled with air from the room. Okay, so using my lungs, I took in a breath, pulled in gas from the room around me, and then blew it into this balloon and tied it shut. Okay, so this balloon contains just air from the room. Now, the process is going to go like this. I'm going to turn on this Bunsen burner. And in a moment, I will turn the lights off just so that we can see the flame a little bit better. But I will be using this pole, and I will be attaching this balloon to the end of the pole, like this. And I will then be holding the balloon over the flame. And we're going to look for signs that a chemical reaction has occurred. And we're going to record our observations. So right now I'm going to turn the lights off so we can see the flame a little bit better. Now it's a little bit dark in here, but hopefully you can see the flame and you can see the balloon. Okay, you might predict what's going to happen when I hold the balloon over the flame. Get ready for it. 3, 2, 1. And boom goes the dynamite. There it was. The balloon popped. Okay, so that was balloon number 1. Now, that was just air from the room. And I want you to pause and think, did a chemical reaction occur or not? Now, we saw that the balloon popped. I have little pieces of balloon here. And you heard a popping noise. Did you see anything other than the balloon breaking? Not really. Okay, now in this case, no chemical reaction occurred. The balloon's made of rubber. The rubber stretches out. And when I held it over the flame, it caused the rubber to break. And when the rubber breaks, it shrinks down to its beginning size. And when that rubber moves quickly, it causes air particles to move quickly, and that in turn vibrates air particles nearby and eventually hits your ear as a popping noise. Okay, so that noise is just due to the rapid movement of the rubber. Now, reaction number 2 is going to involve another balloon. It's going to be the same color, the same size. It's going to look the exact same. But inside of the second balloon, there is hydrogen gas, that's H2, and there's oxygen gas, which is O2. So in terms of the contents of the second balloon, it's H2 plus O2, hydrogen gas plus oxygen gas. Now I'm again going to start the Bunsen burner, and we're going to do the same process for the second balloon. And I want you to look for any difference between the first balloon. We kind of did that as our control. That was showing you how much noise the balloon would make just popping. And we're going to contrast that with a chemical reaction occurring when the balloon breaks. I want you to pay close attention to what you see, what you hear, and if you were here in the classroom with me, what you would feel. Okay? So same setup, same process. I'm going to use the hydrogen balloon now for the second reaction. This is our balloon of hydrogen and oxygen. Okay. We are ready to begin. Second reaction, hydrogen gas and oxygen gas. Here we go. 3, 2, 1. Hoo-wee! Now, I don't know how that turned out on video, but hopefully you could tell. That was a chemical reaction. Much bigger. You could see energy being produced in the form of visible light, right? You could see like a fireball. I could feel the concussion, I could feel it as it exploded. And you could also tell some of that energy being released as vibration sound waves as well, right? That was much, much louder than the first one. Okay, so it's an example of a chemical reaction and an example of two gases reacting and energy being released. That's what's called an exothermic reaction. Energy is released during the process. Hope you like it.